All right, let's talk about finding the volume of a cone using calculus. We're going to look at the volume of a cone. We're given that it's 12 inches in height with a base radius of 5 inches. If I look at the profile, right, of this cone, I see a triangle here. And the idea then is we are going to integrate the cross sections. If we were to vertically go up to some height and look at a slice, right? What would we see? So say I go up to a certain height of Y and come across and slice, take this piece out and then flip it up. What would we see? Of course, a circle, right? Because this is a cone. And these circles, I'm going to call the radius of that circle A. So that will be that length there, right? The diameter would be all the way across 2A. And the area of that circle, of course, is pi times the radius squared. And notice the value of A as Y varies from 0. So this is Y equals 0 here up to Y equal 12, right? Is what we would be integrating over. So at some, as Y varies from 0 to 12, notice the value of A is getting smaller, right? Obviously, those circles are getting smaller and smaller as we get to the top. So the first job will be to express this area as a function of Y. So basically, I need to know what A is as a function of Y. Once I have that, I'll have the area, cross-sectional area as a function of Y. And then we're going to integrate that from Y equals 0 to Y equal 12. So how do we do that? Well, we can see if I look at, sort of the dropping as I've done here, a line perpendicular to the base. I want to focus on just this half here. And we have a right triangle here, the big right triangle here with a base of 5 and a height of 12. And then this little triangle here, where we've made our slice at an arbitrary height of Y, that base of that triangle is A. So the question is, what's this height of this triangle? Notice these two triangles, this angle is 90 degrees, same as that one. They both share this angle, and therefore these angles must be the same. So these triangles are in proportion to one another, right? They're similar triangles. So their side lengths are in proportion. That's how we're going to be able to find the value of A. So what is this height? We know the entire height is 12. We know the height up to this slice is Y. And so what's left over is obviously 12 minus Y. And so from the fact that we know these two triangles are similar, we can say for the small triangle, its base A to its height, which we just found to be 12 minus Y, that ratio is equal to the big triangle's base 5 to its height 12. And so we have this proportion that we can solve. I'll just multiply both sides by 12 minus Y, and I get that A is 5/12 times 12 minus Y. And then I want to square A. And so what is A squared going to be? That's going to be 25 over 144 times 12 minus Y squared, right? If I square that out. And so I now know what my area function is. It's all of this times pi. And so I'll just write this as 25 pi over 144 times 12 minus Y squared. There is my area as a function of Y. First of all, I think that's the first thing we're asked to find. And just check and make sure this makes sense, that your radius is indeed true, that this is the correct formula for A. Notice when Y is 0, the value of A is 5. And as Y gets bigger, A is getting smaller and smaller and smaller. By the time it gets to 12, it goes to 0. So is it true when Y is 0, do we get 5 out of this formula for A? Well, if I plug in 0 for Y, I get 12 minus 0 is 12. 12 times 5/12 is 5. So that is correct. And then by the time Y goes to 12, A should go to 0. And if I plug in Y equals 12 into this, I do get 0. So it's working. Okay, so now the volume is to integrate. And again, we're integrating from y equals 0 to y equal 12, this cross-sectional area. So I'll pull out this constant multiple, 25 pi over 144. And there's the integral we want to find. Now to find this integral, you could, squared. You could square this out, FOIL this out, and find the antiderivative that way. Some of you, I think, can know the antiderivative by doing the substitution in your head. I'll just formally show the substitution. If I do u is 12 minus y, then du is negative 1 dy. So we have this relationship. And then also I'm going to change my limits, right? Because I'm going to go to this new variable. The old limit was y equals 0. And if I plug in 0 for y, I get u is 12. And when y is 12, the upper limit, the value of u is 0. And so this integral becomes, the dy is the negative du, so we'll pull the negative out there. You still have the 25 pi over 144. And then we're integrating from 0 to 12, but now when it's 0, we're going to 12, and at 12, we're 0, so we're integrating from 12 to 0. 12 minus y is u, and again, dy was negative du. Now, this is the integral you can evaluate. I would just say, you can leave it like this and evaluate it. If you don't like the fact that we have an upper limit that's bigger than the lower limit, you can simply change those limits. Remember what that does. If I change the limits to 0 to 12, it changes the sign out here. So this will be just positive 25 pi over 144. Don't have to do that, but I did it. So this will be 25 pi over 144. The antiderivative of u squared is 1/3 u cubed. And we evaluate that at the upper limit of 12, lower limit of 0. I'll let you do that. Hopefully you can confirm that you get 100 pi, interestingly enough. And that is the volume in square inches, cubic inches. The volume in cubic inches, excuse me, right? Because the dimensions were given in inches. And so that is the answer to the problem, finding the cross-sectional area and then integrating it from 0 to 12. All right, I hope this is helpful for this example.